Welcome to this lesson on the properties of numbers and the properties of equality. Let's go over these properties. So the first one is the commutative property, and that's when you add or you multiply, the order does not matter. So for example, 2 plus 3 is 5, and 3 plus 2 still gives you 5. So the order in which you add does not matter. And the same applies for multiplication. The product of 4 and 5 is 20. And then 5 times 4 is also 20. So the order doesn't matter. Next is the associative property. That means when adding or multiplying, it doesn't matter how the numbers are grouped. And think like an association is a group. So for example, 3 plus parentheses 2 plus 1 would give you 6. And 3 plus 2, that's 5, plus 1 would also give you 6. So the numbers that are grouped together, it doesn't change the final sum. And same applies for multiplication. So 2 times 4 times 6, that would be 2 times 24, which is 48. Or 2 times 4, which is 8. 8 times 6, that's still 48. The next is the distributive property, which we've already talked about when solving equations and when simplifying expressions. That's when multiplying by a sum, you can multiply each addend, which means the numbers that you're multiplying or that you're adding together. You can do those separately and then you can add. So, for example, I can multiply 3 times 2, which is 6. Plus 3 times 4, which is 12, and then add those together, you get 18. All right, next is the identity property. For addition, the sum of any number and 0 is still that number. So for example, 4 plus 0 is still 4. So think about identity, it's yourself. If you add something to 0, it still gives you that something back. And the same applies for multiplication, except for multiplication, the product of any number and 1 is that number. So 8 times 1 is 8. Anything multiplied by 1 gives you that same number back. And the last property of numbers is the inverse property. And there's two different inverse properties. There's the additive inverse. And that's when the sum of any number and the negative of that number is 0. So 7 plus negative 7 gives you 0. And they're inverses because it's a positive and a negative. Or you could also think about it, addition and subtraction. The multiplicative inverse is the product of any number and its reciprocal, which means a fraction flipped, is 1. So 3 times 1 over 3 gives you 1. And 3 is the same thing as 3 over 1. So that is the reciprocal. We have flipped 3 over 1 to give us 1 over 3. And when you multiply those together, let's actually multiply them and prove it. So remember, when you multiply fractions, you go straight across. So numerator times numerator, 3 times 3 is 3. Denominator times denominator, 1 times 3 is 3. And we all know that 3 divided by 3 is 1. Okay, go ahead and pause the video now and try the practice, and then we will pick back up with properties of equality. Okay, so you should have completed the practice. You can check the answers with your teacher. Let's move on to properties of equality. So the first one is the addition property, and that says that you can add a number to both sides of an equation and it still keeps the equation true. So for example, when you're solving equations, remember you do the inverse. So I can add 3, and that doesn't change the value of the equation. It still keeps that equation true because you did the same thing to both sides and you kept it balanced. The subtraction property is very similar, except it says you can subtract a number from both sides of an equation. So in this case, minus 4 still keeps the equation true. Multiplication property says you can multiply both sides of an equation by the same number. So here I can multiply both sides by 2 without changing the value of the equation. And then division property, you can divide both sides of an equation by the same number. So here I can divide both sides by 3. All right, next is the reflexive property, and that is when a number or a variable equals itself. Oops. So for example, 10 equals 10 or A equals A. You see that property a lot in geometry proofs. Next is the symmetric property. If A equals B, then B equals A. So an example of that, when you have x equals 3, that's the same thing as 3 equals x. They mean the same thing. It doesn't matter which order you write them in. The transitive property, if A equals B and B equals C, then A equals C. So an example of that, if x plus 2 equals 10 and 10 equals y, then x plus 2 equals y. So I can basically change the 10 to a y because of the transitive property. And then the last one is the substitution property. If A equals B, then I can substitute A with B. So if A equals B and A plus C equals D, I can substitute out this A for this B because I know they're equal. And it doesn't change the value of the equation. It still keeps the equation true. I'm just substituting one value in for another because they're equal. And the substitution property is actually a special type of transitive property, so they are similar. Okay, you can go ahead and complete the practice. I did want to go over one thing on the practice that wasn't in the notes. So all of these, you're just saying what property is applied. But when you get down here to practice 2, let's go over one of these together. This is called a 2-column proof. And basically you're just saying the steps of an equation and why those steps are true. So here we have an equation, x plus 5 equals 10, that was given to us. So the next thing we would do to solve this equation is we would subtract 5 from both sides. So if you want to write it out like this, minus 5, minus 5. And we can do that because of the subtraction property. We can subtract the same number from both sides of an equation. And then I'm going to simplify here. So we know 5 minus 5 is 0. So I can just bring my x down. 10 minus 5 is 5. And there we were just simplifying. So I'm just going to put simplify as my reason. Okay, you can stop the video now and complete your practice and check it with your teacher.